Hello guys, this is week 9 of computational thinking course, and this week we're gonna dive into the Python, the programming language. And till now, you were dealing with problem solving in general. You learn problem decomposition, pattern recognition, right? Abstraction, logical thinking, and the last week you dive into data. Now we will bring all those pieces together and we will translate the solutions that you were dealing with into computer language. And before I forget, let me introduce myself also. I am Şebnem Eşsiz and I work at Bioinformatics and Genetics department at Kadir Has University. This department will also tell you about how computers are necessary in almost every field today. We use mainly computers for analyzing biological data. So now let's start then, and let me share my screen. Okay. So when we say programming, the first thing that we need to mention is algorithm, because we convert algorithms, we convert solutions to a problem to the computer language. And algorithm is an abstract, detailed computing instruction that solves the problem. It is like a recipe. So let's say if somebody doesn't know anything about washing clothes in a washing machine, he never used a washing machine before. So you need to give a recipe to them, but you need to be very precise about the steps. So you're gonna tell, this is one algorithm here. Load the laundry, add detergent and additive, switch the machine off. If clothes are wool, select a wool program, otherwise select a normal program. Start the program, wait until done, and don't forget to remove the clothes. So this is the algorithm for washing clothes using a washing machine. Now, if you can go to the mathematical problems also. For instance, if you want to find maximum number in a list, how will you prescribe a prescription for finding that? So let me show you. Now let's think together. If I give you just four numbers, how do you find the maximum number in the list? No, right now, just try to capture what your brain is doing, because you're gonna tell to somebody else how you did it. Okay, you just saw 13 immediately because you can scan the data and you compare binary, like two numbers, and pick the one. What if the list is a little longer? Now what is your brain doing? You are scanning through the numbers, right? And you are keeping the larger number in the memory, mainly in your memory. So if you want to prescribe this to somebody else, you're gonna say, read the first number. And let me call this step 1. Then you're gonna say, read the next number in the list. Right, let's call this number 2. Now what did your brain do? It compared those two numbers, right? If number 2 is larger, keep that, we should put number 2, the number in step 2 is larger, keep that number in your memory. If not, keep number 1 in your memory. What will they do next? Now they read the first two numbers. They're gonna read the number after that, right? So instead of writing that explicitly, we can say go to step 2, right? Because they're gonna read the next number in the list. So let's check our algorithm now. It's our first algorithm. I'm reading the first number, 5. Then I'm reading the next number in the list, which is 6. So number 2 is 6. If 6 is larger, keep that number in your memory. It is, right? So I'm gonna keep 6. I'm not gonna go to the rest because my first sentence is true. So now I'm going to here, and in my 6 is in my memory. I forget about 5 actually. So right now I went to the next number, which is 9. Is 9 larger? Yes, I'm keeping 9 in my memory. Now I'm going to step 2 again. 13. Is 13 larger than 9? Yes, so I'm going to keep 13. Go to step 2. Now I came to 2. Is 2 larger than 13? No. Then I'm going to this statement. If not, keep number 1 in my memory. Number 1 was 5, right? Now I'm keeping 5 in my memory. So there's a mistake in my algorithm. It is not the right algorithm. I need to modify this. How can I do that? Let's think, because it's worked till here, right? But we failed when we come to 2. So instead of here, read the first number and keep that number as your max. So you're gonna keep this number in your memory as your max. Read the other number. Keep that number in the memory. Let's change this sentence a little. Keep this number as your max. If not, we won't do anything. Okay. So instead of keeping the first number, now I'm keeping something called max in my memory. Let's start one more time. 5, I read the first number, 5, and keep that as my max. So my max is now 5. I'm keeping that in my memory. Read the next number, 6. If number 2 is larger, keep this number as your max. Let's put a number here also. So is 6 larger than max 5? Yes. So I'm making this 6 as my max now. I'm going to step 2, reading the 9. If 9 is larger, keep this number as your max. Now my max is 9. Go to step 2. 13 it is larger than 9, and I'm keeping that one. Go to step 2 again. Now that problematic part came. Is 2 larger than my max? No. So I'm not doing anything, and because 2 is not larger than my max, so I'm going to step 2 again. Now I'm reading 78. What was our max? It was 13. We didn't change it in the last step. So this algorithm will work. You can try it. I got tired, so I'm stopping here. But do you see, this is very primitive steps that we define. And we are mainly imitating what our brain is doing here, but we are just telling what brain is doing to somebody else as a recipe. So here you are seeing the same thing that we did. Max is list, blah, blah, the 0th element. At the end of our programming class, you will be able to understand this program. So program is just the realization of an algorithm in a specific programming language. So our algorithm was this, right? We just convert or translate that into the computer language. Why do we need that? Let's see those parts now. Because CPU, computer, only understand machine language instructions, binary, zeros and ones. It is either on or off. It is inconvenient for humans. We cannot write any commands or anything in this language, zeros or ones. So programming languages, they hide complexity of the machine language. They provide more abstract constructs and make programmer, mainly human-machine interaction efficient. And there are different programming languages which are designed for different use cases, support different programming styles. We're going to see that a little later. And they have different advantages and disadvantages. So let's do it one more time. There's high-level computer language designed to be used and understood by humans, which is programming language mainly. Then there is the computer, CPU's language, which only computer hardware can only understand. And programs are converted to the lower level language, either by compiling or interpreting. Here, Python is an interpreted language, but I will briefly mention compiling also. Compiling scans the entire program and translates it as a whole into the machine code. And it generates an intermediate object which further requires linking, and that makes it require more memory also. So it translates the whole code into machine language. Now Python is different. It is interpreted, and let's see what interpreter does. Interpreter analyzes and executes the source code instruction by instruction. So it doesn't read the whole thing. And interpreters simulate a computer that understands a high-level language. And it's called here, for instance, in Python virtual machine. And it directly behaves like a computer, and it converts that to the machine code. Interpreted languages are like Python, Java, and compiled languages are C, C++, and Fortran. Now we will continue with Python. You can go to in order to download the latest version is 3.8, but if you want it in your local machine, then you can go to the Python's official website and download it. It's free. Or we can do it in this class. We're going to use Trinket online versions. And I'm especially advising the last one because it's called Python Tutor. You can just cut and paste your program there. And it shows with an arrow, line by line, the execution and the output. So if you are confused about something, the line execution, then you can use that. Now I will start with the elements, components of the programs. Now, elements of programming, imperative programs. There are 4 components: variables, assignments, expression, and control structures, which will control the execution of the statements. So variables are like placeholder for values, and they point to the positions in the memory of the computer where values are stored, and you can change the value of a variable over time. And values have different data types: lists, strings, numbers. We're going to see all these data types. But for now, variables are placeholders, so they point to the values. Now, what are the different data types? You can have numbers. There are 3 different numbers actually, but we're just going to see the first 2. Integers, which are whole numbers, and you can have floats, which has decimal. And strings are the text variables, which we store as strings. You have Boolean truth values, true or false, and collections, tuples, lists, sets, dictionaries. Here in this class, I'm just gonna show you the list actually today. Now, let me go to when we come to this dynamic typing, let's go to the website that we're gonna type our commands. And here is the Trinket link. So I click to that, and let me share that with you also. Here we go. So now you are seeing the main window in the Trinket, and let me make it full screen. So here, I'm gonna go to home, and on here, I'm gonna select Python. Right now, I have this file. Again, you can write your program into a separate file and save it as like a Word file and TXT file or think it like that with the extension .python, and you can execute that from here as run. Or the other option is directly entering commands to the console and seeing the output after each execution. So here we said the type of variable is assigned to the values data type, and during the runtime, a variable can take values of different types. Let's see what I mean. So our first data type, we say this number, and let's say it's an integer, it's a whole number, x is 15. Now, right now I'm typing in Python. There's a special function called type, which will show us the type of the data. So here, 15 has integer, or you can do the same with the variable name also. Okay, we have an integer. Now let's say x is now set to 6.8. Now x will be assigned to a float. And when we look at that, type x, it's going to give us float. So you can change the data type during the runtime. And couple more things. This one, I'm saying x equals to 6.8, I'm doing an assignment. I'm directly assigning a value to the variable. The other way to do the assignment, again, the assignment statement has the equal sign. I'm setting variable equal to something. But on the right-hand side, I can have an expression, okay? X times 2 plus 1, let's say. Now, this is an expression, the right-hand side, and that expression will be evaluated first, the right-hand side, then that value will be assigned to the left-hand side. Normally, when we are typing equations, we don't use the same variable name on both sides. But in Python, since the right-hand side is evaluated first, and this won't create any confusion. So our current x is 6.8. It's going to multiply that with 2, and it's going to add 1, and that value will be assigned to new x. So when I say x, I'm going to see 14.6. So this is my new value. Now, if you want to open a program, a Python script, this is how we're going to do. I went to the pencil sign, then I'm going to upload a file, and let me show you. These are I just prepared this for different operations. These are arithmetic operations with numbers in Python. And this is a Python script normally, but I just put comments for myself to remember. And do you see the number sign? It means it's just a comment, so it doesn't execute these lines, Python. Now, addition is shown with plus sign. You know these things. Minus is a subtraction. Multiplication in Python is shown with the star. Division is regular division. There are 3 different things here. Not the last one is not that different, but modulo and floor division. Modulo is the remainder function. So if you divide A by B, and what will be the remainder of that? So it is like a mod function. And I'm going to show you these with examples. Floor division is, it's going to do a regular division, but then round that number to the integer, to the closest integer. So let's see that. Now I'm going to go back to the console and let me show you. For instance, A, let's say A is 15 and B is 4. So A minus B or A divided B, you can do all those operations. But let me show you the modulo function, A modulo 4. So you're going to divide 15 by 4, and the remainder will be 3, right? 3 times 4 is 12, so the remainder will be 15 minus 3. Okay, this is the modulo function. For instance, 4 modulo 2 is 0 because there is no remainder. So in Turkish, it is kalan. Now, in the other floor division is A divided by B. So 15 divided by 4 is what? If I divide it regularly with a regular division, it is 3.75. So when I do the floor division, it's going to round up that number to the decimal, before the decimal. Now, there are also truth Boolean type of variables. And here we are seeing the operations with those Boolean variables. Negation, not A, that means conjunction A and B, and disjunction A or B. Now, let's see what we mean by these operations. And now I'm going to go to the console. So we say Boolean variables are either true or false. So let's say A is equal to true and B is equal to false. So when I say not B, negation, Not B, B is false, so not true is false. It is binary, either true or false. Now, think there is conjunction and disjunction, right? So let's say A or B, or A and B. What is the difference? For instance, if I'm telling you, you need to do either this first assignment or the second assignment to get 10 points from this class, is one statement. Or if I say you need to do both exercise 1 and 2 to get 10 points. So in the AND case, you have to do both of them to get some point. In the first example, you need to do either, okay, to get the 10 points. So for OR, just one exercise is enough, okay? And just like that, one true is enough. So when I look to this statement, A is true, B is false. So true or false, just one true is enough to have the points, and that is true. When we look at to A and B, now you need to do the both exercises to get 10 points to get true. That means both of them needs to be true for the final result to be true. And here in our case, A is true, B is false. So true and false give us false, okay? Or is the disjunction and the and is the conjunction. And there's a precedence, just like the arithmetic operators, not comes before and comes before or. So you need to evaluate not before and. For instance, let's say C is also equal to false. Now, if I write a statement like A and not B, or C, what will Python return me? Let's see. We say it not will be evaluated first, so not B. B was false, not B is true, right? So this part is true. What comes next? And comes next in the precedence. So true, A is true, true and true is true. Now this whole expression is true. And when we come to the OR part, true or false, since C is false, so true or false will give us true, okay? There's a precedence also in these operations. So we can also have strings as variable, and we show the string as, let's say we have text name is equal to, this is my variable name. This is a string. We show the strings with the, or either with single quotation mark or double quotation marks. So when I say type text name, now I will see string here, okay? Or you can just say y is equal to hello world, for instance. That will be also assigned as a string. And when I say y, it's going to print me that string. Only in the string, it may not contain any special characters if no encoding, other encoding is specified. Okay. We also have lists, and we have some string operations. Strings are like lists. But I'm going to stop here and go to the PowerPoint slides now. Now, let's go back to the pencil and let's see what else we have. We saw the negation, the conjunction, disjunction, and there's a precedence. Not is evaluated before and is evaluated before or. Okay, now there's also relational operators. So these operators, they compare two variables. Less than is shown with the right-hand side, the right column is for the Python, and greater than is shown with the bigger sign. Less than or equal to, greater than or equal to. Equal to is with the two double equal signs. Just be careful with that. With single equal, we are making assignments. When we use two equal signs, we are comparing two things. And there is not equal to also, which is exclamation mark equal sign B. So these are like relational operators, and with these, we are asking questions to the computer actually, and the computer only answers binary, either true or false. So let's see that one too. I'm going back to the console, and now I'm gonna, for instance, I'm gonna ask, is 3 larger, sorry guys, is 3 larger than 2? So this is a question, is 3, I'm asking a relational, greater than 2? And the answer will be true. Or for instance, I can ask, you can compare strings also. Alt is larger than, so this will be also have, it just goes alphabetically. You can compare strings too. Now, let me put one more example. If I say 3 times 2 times 3 and plus 4, now I'm printing this exclamation mark, equal sign, if I can do that. Now I'm going to put the parentheses, 2 times 3 plus 4. What am I asking is the expression on the left-hand side not equal to expression on the right-hand side? So the right-hand side is 2 times 3 is 6, plus 4, 10. What about the precedence here? Multiplication comes before addition, right? So 2 times 3 is 6, plus 4 is 10. The question is 10 not equal to 10? So one more time, the way that I'm asking question is 10 not equal to 10? And the answer is false. Okay, so these are the relational operators. And there is also one last thing, let's do that. You can assign, let me go down, single variable to an expression, or you can, these are allowed, you can assign single expression to the multiple variables. The value of expression is assigned to all variables, and all variables point to the same value in the memory. Or you can separate the variable names with the comma, and you can assign each variables to the corresponding value. For instance, variable 1 will be assigned to expression 1, and variable 2 will be assigned to expression 2. Now, till here, we saw different data types, strings, booleans, numbers, right? Now let's see one from the collection type. It's called list. We can have list of numbers, or we can have list of anything, actually, any object. And here, the second one, weekdays, is equal to Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And we show the list with the square brackets, actually. Square brackets shows that that variable is a list, and we can access to the individual items of the list using brackets. So for instance, if I say weekdays square brackets 2, it's going to go to that index 2 and print that element. Or weekdays 6 will be, the indexing starts from 0, don't forget this is a little different. So the for instance, weekdays 0 is Monday, weekdays 1 is Tuesday, weekdays 2 is Wednesday. So when I say weekdays square brackets 2, it's going to print me Wednesday. Now, you can change the list numbers. Each variable in the list is separated by a comma. And for instance, here is my original list. And if I say my list square brackets 3 is equal to world, then it will go, and this is the 0 element, A, B is the first. So it's going to go to the third element and replace this D with the word. Okay, so let's try to predict the output of this following piece of code. And if I say my list 1, it's going to go to B. My list 4 will print hello. You can also access from the backwards. -1 is the last element, so it goes like from right to left. And my list -2 will be D. Here is the interesting one, my list 4, and then another square brackets. My list 4 will return what? Hello. right? Strings are also implicit lists. So each character in the string will be recognized as a list member, think it like that. So my list 4 returns hello, and the first element of that will return us E. By the way, just try these. Stop here during the lecture and just go to the web Python and try the output of these lines. Now, there are cool things. I'm just going to show a couple of things, easy things. You can merge strings with the addition sign. So the operations, arithmetic operations are also valid for strings. You can use multiplication also. For instance, if you say hello times 2, it's going to print hello, hello 2 times. And you can access to the individual characters with list indices. That is what we did. For instance, hello inside quotation mark is a string, and if I say 0, it's going to print H. If I say hello 1, it's going to print E. You can also check whether a substring occurs inside the string. H, E in hello. It's a question again, whether this is inside hello, and the answer is always true or false. So it is true. However, we don't have ha in the hello, so it is false. And this is true for the lists also. You can measure the length of the list. There is a specific function called len, and it returns us the length of the list. Last but not least, we saw type, right, as the function. Len is another function to measure. Now, one of the most usable ones is the print function. It's a function that prints the value of an expression to the console, the standard place. And here we are seeing how we print. We use this, I think, or you can just say number and it will return you 125 also. I said last but not least, but there's one last piece. The variable names must start with, in Python, with letter or underscore. The remainder may include in digits, but it cannot start with the digits. Umlauts are not allowed. The name should not be a keyword, the built-in keyword from Python, and the names are case sensitive. Just convention, you don't have to, but variables start with a lowercase letter also. So which ones are allowed, recommended? Let's see. Foo is allowed. Tofu is not allowed because it starts with a number. Foo12 is okay. Underscore foo is okay. If is not okay because it is a built-in Python name. Shebnem's variable is also not okay because it starts with sh. Okay, guys, I'm gonna stop here. Now let's do a revision exercise together about what we learned till now. So the following listing shows several steps of execution of a program. For each step, write down the values of types A, B, and C. Let's start with X here. If I type X equals to 4.2, what is the value? What is the type of data of X? X is a float. Now I go to the next line. Y is equal to X divided by 2. 4.2 divided by 2 is 2.1. So Y is a float now, and its value is 2.1. Now this is a interesting operator. Plus equal. Any arithmetic operator with the equal sign is equivalent to, this is a shorthand notation in Python. So X, this means X is equal to X plus 4. So our current X is, and we can do that, for instance, if there's a star here, that means X star equal 4. That means X is equal to X times 4. So you are sort of adding another X to the right-hand side when you see this shorthand notation. So X was 4.2, and when you add 4, now X is 8.2. Never mind this arrow sign. So X and Y are equal. We are doing multiple variable assignment to the multiple values. X is true now, and Y is false. Now, the type of data, they are both Boolean, right? Now I go to the next line. X is equal to not X and Y. Which side will be evaluated first? The right-hand side will be evaluated first, and that value will be assigned to the X. Now, not X. X is true. not X part is false, right? The first part is false. False and false is false. So X is at this point false. Now I'm going to the next line. And the type of the variable for X is Boolean, right? A is this square bracket separated by comma variables, which is a list. So type of A is list. Now, let me do this I-type stuff so it shouldn't give errors. Now, at this point, B is A square bracket 0. I'm calling the list A with the index 0. And this first element of this list is hello. So B is now hello. It's a string. And when I go to next line, C is equal to B4. And B is hello. If I say hello 4, it's going to be 0, 1, 2, 3, 4. So C will be assigned to O, and the type of the data will be string. Now I'm going to the last line, and not A1. What was A1? I forget about that. Now I'm going back to the A, the list A, 0, 1. So X is my A1, and we assign something to X. What was that? Do we remember? Not X is true, false and false. X is false, and not A1, not false is true. So let me repeat the last step. It is a little confusing. Here we found X is false. That is our last assignment to X. And when I say not A1, I'm finding X, and X is false. So not false is true. So for the last one, Y is true, and type of the string, type of the data is Boolean. So you will have a quiz following the lecture, and this quiz will be just like the exercises that you saw here. You're going to predict either the value or the data type of what we did. Now I'm going to stop here so you can take the quiz.